take a look at another functional equation. It is a shortlist problem from the International Mathematical Olympiad 1996. It says, let f from real number to real number be the function such that the absolute value of f of x is smaller or equal to 1 and f of x plus 13 over 42 plus f of x equals f of x plus 1/6 plus f of x plus 1/7. And we need to prove that f is periodic. Different from other functional equation, we usually try to find all functions satisfy the given condition or maybe find one function. But here we need to prove the periodicity of the f. And yeah, so let's see how to solve this one. In the problem, we can see some numbers like 13 over 42, 1/6, 1/7. Yeah, this is a kind of signature of the IMO because, as you know, every year we'll have a 6 problem. And every problem counts for 7 points, so the total points will be 42. And yeah, let's denote A to be 1 over 42. So in this case, we can see that 13 over 42 is actually 1/6 plus 1/7. Also, 1/6 is 7a, 1/7 is 6a, something like that. And also this is 13a. So actually we can rewrite the original equation as f of x plus 13a equals plus f of x equals f of x plus 7a plus f of x plus 6a. Actually, we can try to rearrange the term as f of x plus 6a minus f of x. We move this term to the right hand side and we move this term to the left hand side. So it will be f of x plus 13a minus f of x plus 7a. Okay, we can observe that the argument between this one and this one is 6a. So 6a. Also for this argument and this argument, there is a difference of 6a. And we can also observe that the argument from here to here is we have a difference of 7a, which means that if we just substitute x to be x plus 7a here, on the left hand side we will get f of x plus 7a plus 6a minus f of x plus 7a, which will be nothing but f of x plus 13a minus f of x plus 7a, which is actually the right hand side of the original equation. But for the original equation, if we replace x by x plus 7a, we will get f of x plus 20a minus f of x plus 13a. Yeah. Sorry, this should be 14a. Which means that we can simply adding 7, and then become this one, and then this one adding 7, it becomes f of x plus 20a minus f of x plus 14a. We can repeat this procedure up to f of x plus let's say 42. So it is 48a minus f of x plus 42a. So we can see 42a here as we denote a to be 1 over 42, which means that 42a is actually 1. Okay, for the original equation, we can rearrange the term in another way, which is f of x plus 7a minus f of x equals f of x plus 13a minus f of x plus 6a, which means that we simply exchange this term and this term. And actually we can also repeat the same procedure so that it will be all the way up equals up to f of x plus 49a minus f of x plus 42a. And we also have the term f of x plus 42a here. We have f of x here, f of x here. So maybe we can call this one equation 1, call this one equation 2, and then we just look at the very left and the very right of equation 1 and 2. We have we can write it here as f of x plus 6a minus f of x equals f of x plus 48a minus f of x plus 42a. And also we have f of x plus 7a minus f of x equals f of x plus 49a minus f of x plus 42a. Of course, we can just substitute them, and then we will get f of x plus we can just subtract the second one by the first one. So we can get f of x plus 7a minus f of x plus 6a equals f of x plus 49a minus f of x plus 48a. Actually, we can substitute x by x minus 6a. So then we shift this term back to f of x. So it will be like f of x plus a minus f of x equals f of x plus 43a minus f of x plus 42a. Yeah, we'll see that the difference between these two arguments is a. The difference between these two arguments is also a. And the difference between this argument and this argument is 42a. So they are just a integer multiplier. So actually we can also rearrange this equation as f of 42a, f of x plus 42a minus f of x equals f of x plus 43a minus f of x plus a. Yeah, and still we can repeat the procedure as the above. So we can just change x to be x plus a, and then x plus 2a, dot, dot, dot. So it will be all the way up to x plus 42a. So finally, it will become f of x plus 84a minus f of x plus 42a. Yeah, so now when we just look at the very left and the very right, we have f of x plus a, 42a is 1 minus f of x equals f of x plus 84a is 2 minus f of x plus 1. So we have the difference of 1. Also, we have the difference of 1 here. Okay, so here we get this, like we can call it equation 3, which is really useful here. And yeah, and of course, using this one, we can also repeating procedure by exchanging x by x plus 1, x plus 2, all the way up to x plus, let's say, n, when n is an positive integer. So we have f of x plus or n minus 1. So we have n minus f of x plus n minus 1. Yeah, something like this. Yes, something like this. Yeah. Okay, so so here, let's say if there exists x sub 0 such that f of x sub 0 plus 1 minus f of x sub 0 is, or maybe we can just take, is not equal to 0. Or maybe we can say that is f of x sub 0 plus 1 minus f of x sub 0 equals k, which is not equal to 0. And yeah, so referring back to this condition, which is really useful for us, and yeah, we know the absolute value of f of x should be smaller or equal to 1, right? So, which means that if we have let's say f of x minus f of y by the triangle inequality, which should be less than or equal to the absolute value of f of x plus the absolute value of f of y. And this is smaller or equal to 1, this is smaller or equal to 1, so it is smaller or equal to 2 for all x, y, like this. So now if we assume that k is not equal to 0, and now let's pick n to be larger than 2 over k, the absolute value of k. Maybe k is a positive value or a negative value, but just pick n to be larger than 2 over absolute value of k, and we will have f of x sub 0 plus 1 minus f of x sub 0. So this one plus f of x sub 0 plus 2 minus f of x sub 0 plus 1. And then all the way up to f of x sub 0 plus n minus f of x sub 0 plus n minus 1. Yeah, we have this term, and as much as we know, every term is k, and they should all be equal. They should all be equal to each other, which means that this one, when we take the absolute value, take the absolute value, it should be equals to n times k. N times k. And actually, we can just cancel the terms, because this is actually a telescopic series, which means that we can cancel f of x0 plus 1, f of x0 plus 1, and then f of x0 plus 0 with this term all the way up to here. So this is actually equal to f of x sub 0 plus n minus f of x sub 0. And referring back to here, we should have this is smaller or equal to 2. However, we have this one, which is equals n times k. And as much as we pick n is larger than this one, so we have this to be larger than 2 over we should have an absolute value here. So it is like 2 over absolute value of k times the absolute value of k, which is 2. Or here we only have strictly larger sign. So here we also only have strictly larger sign. In this case, this expression is smaller or equal to 2, and also it is strictly larger than 2. So this is conflict, which means that there doesn't exist any value of x0 such that this expression is not equal to 0. In other words, f of x plus 1 minus f of x equals 0 for all x is a real number. In this case, we have f of x plus 1 equals f of x, which means that f is periodic. Periodic. It doesn't really mean that 1 is the period, because when we say f is a periodic function, it means there exists c which is larger than 0 such that f of x plus c equals f of x for all x in the domain, of course. And for the smallest number of c, there are infinite many c will satisfy. If there is 1, then there will be more than 1. Just say if we have this expression, we can also write that f of x plus 2 equals f of x plus 3 equals f of x, so on and so forth. So there will be infinite many. As long as this number is a multiple of 1, then all this equation will be satisfied. But the smallest number of c will say it is the period of the function. But up to here, we know f of x plus 1 equals f of x, but we do not really sure that 1 should be the period. Let's say it may be the fractional of 1, or at least we can construct a function like if we have f of x plus 1 over 42 equals f of x, then if we just substitute back to the original equation, we will have this term equals to this term equals to this term equals to this term. So it will all be satisfied. which means that 42 is a sufficient condition, and 1 is the necessary condition. But we don't know what is exact real number unless you can construct a function with period 1 which also satisfy this condition. So we can say that the period, although it is not required by this problem, the period should be one of the following number, which means it is an integer fraction of 1 or the integer multiple of 1 over 42, which is 1, 1/2, 1/3, 1/6, 1/7, 1/14, 1/21, 1/42. Either of these one should be the period of f, but yeah, we don't really sure unless you can construct. And I think this is the end of this video.